Did someone say coding example? I love coding examples. So I've now got my coding t-shirt on, and we're going to do a coding example using queues. And so our code keys example is where we get to use our queue and we take from one end and insert from the other, and the very special key shift will rotate through there and give us a really cool encoded message that will be really hard to crack. So, coding example. So, we have our NetBeans here, and we need to create a new project. So we come over here, new project. Hopefully you're getting very used to creating new projects. Maybe you can click here or click File, jump over. We just want a new Java application. We're going to call it QFun. Click on Finish. And this will build our project for us. Building our project. So what we need to do once we get our project up is to start exploring how queues work for us. So it's building a new project over here. QFun source packages. Here's our QFun with our main method in it. Here we go. So first thing, we want to test to make sure things run. So QFun, and you're going to go up, press the play button to run it, or as I usually do, I hit F6 to run my projects so I can look down here and see what's happening. So with our queue, we'll need to have a queue and then take items and put them on the end and then take them off the other end. All right, so here we go. QFun, excellent. Things are working. Our NetBeans and our Java are working. Always good to test. You just never know what's happening with these programming languages. All right, so we need a queue. So the queue class, we have a queue. If I could spell, queue. There we go, a queue. And I'm going to call it my queue. Well, actually, let's call it, what are we doing here? So we are coding example. We're building this repeating key that we're going to shift through here. So how about we call our thing repeating key. So this will be our repeating key, and it's going to be a new queue. Yes, all right, so doesn't know what a queue is, so we need to import that. The easiest way with our IDE is to add an import for java.util.queue. And here we are with our repeating key, and we still have another error here. So it says queue is abstract, cannot be instantiated. So I wonder what that's about. Let's go. Let's have a look at. Let's start up. Let's go look at the API and see what that's got to say. So let's go and search for Java API. Oh, there we go. 8Q. Here's the queue. Can you see it? It's an interface. So you can't instantiate an interface. You can declare something using an interface, but when you say equals new and you instantiate a new one, you can't use queue to do that. So we have to use something else. All right, back we go. Equals. So what are we going to use here? Let's see. So let's go back to the API, shall we? So we have an interface queue, and it has some super interfaces. So up the hierarchy. So collection. Yes, we've got some sub interfaces, and here we go. All known implementing classes. So these are the ones that we can use to instantiate a queue. And there's a few there. And the ones we're probably most interested here at the moment are ArrayDeck and linked list. And linked list, right? This is the same one from the list hierarchy where we had an array list and a linked list. And the linked list actually implements the queue as well. And it's a really good representation for it because remember that a linked list we can add and remove from either end with really good efficiency. Now, an array list, you can add to the end of it and remove from the end of it, but adding to the front or removing from the front is a very costly operation. So a linked list is a great way to represent a queue. There's also this ArrayDeck, which was mentioned with stacks as well. You could also use that for your queue. But I think let's choose linked list as our implementation here. So rather than a queue, we could use a linked list here. Need to import linked list. There we go. Now this queue is, as you can see over here, it is generic. So this is what this little E is all about. So we should use that. So what do we want to store in here? What type? Let's have a look back at our specification of what we're trying to do here. What we want to store is this repeating key through here. And we want to store ints in here, all right? So let's jump back over here. Now let's just take this, pop this here, and just to remind ourselves that cannot instantiate an interface, right? So can't instantiate an interface. So that's good. So we want to store ints in here in our linked list. All right, so we can chuck the diamond interface over here and let's store int. Now we've got another error message and it says unexpected type required a reference, but found an int. So I'd say it's referring to this int here. It's the only place there's an int. So what is that all about, I wonder? So all we can store in here, so if we put a string, it's happy with that. So string is a class, and when we talk about classes in Java, we can talk about a reference when we have an object of a particular type. So when we put int, it says required a reference. So string is the reference, but I found an int, and an int is a primitive type. So we can't in generics use primitive types. Cannot use primitive types for generics. Primitive type for generics. We can't do this. And we don't want to put strings in there because that's not what we want to do, right? So what we really want to put in here, all right, so we can put string. It's happy with that, but we want to put an int. So this is where we have these wrapper classes that we can use in here. So Java has a number of wrapper classes for the primitive types. So we can have an integer, a double, we can have a Boolean, for example, in here. So an integer is a wrapper class. So use a wrapper class. And this gives us all the wonders of the int, but as a class as well. So that's really good. That's what we want to be able to do. So now we've got our queue. It's working. Excellent. Now we can add things to it. Repeating key. We can, it doesn't feel right. All right, how do we do this? Let's have a look at the API, shall we? Go back to the API. So here's the API. And if we scroll down through here, we don't want to look at linked list, but it's this, the interfaces of queue. So we've got these throws ones, add, remove an element, or offer, poll, and peek. So these are the ones I want to use. I want to use offer, poll, and peek, but you can use add and remove if you like. So offer is where we add something, and poll is how we get things out. Look, and it talks about FIFO here for the queue, and LIFO for stacks. So I've forgotten already, offer. So we use offer, and I can offer it an int, right? I don't need to say no need for new integer due to auto boxing. So Java has this feature called auto boxing, which is about our primitive class types that we can use. It'll take this primitive type, turn it into an integer class for us, and put it into the queue. And the same happens when we get them out as well. All right, and so we can get something out. So an int test value equals repeating key dot poll, and that'll get us out the value that we've got. All right, so let's have a look. Let's try running this. Haven't run it for a while. It ran. Fantastic. Let's have a look. Let's print out our queue. So SOT control space key. We'll just call it key. Repeating key. So we'll print that out before we add something on, after we add something on, and after we take something off. We'll see what the queue looks like. Not very exciting, is it? We only added one thing to it. So we have an empty one, something in it, and we do a poll, and now it has nothing in it. Yeah, I know, exciting. So let's put some more things in it and see how it grows and shrinks, shall we? So if we jump over to here, the idea is how can we use a queue? Well, we'll use a queue to store all the values of the repeating key in it. And then we'll add things onto it and remove things from it. We'll cycle through it. So here's the sort of thing we might want to store in here. 3, 1, 7, 4, 5, 2, 5, for example. So a series of numbers is what we want to store in here. So in here we now have what I want to put in. Right, so we've got adding things in, taking a few things off. But what I will need to do now is let's create a key. So the repeating key, we'll have an int, and we'll have our repeating key values, I guess. Key values. Oh, well, let's go with initial key. And our initial key will be, let's make it easy so we can sort of see what's happening through here. Make it a bit smaller, shall we? And we want to take this key and add all the items to our repeating key here. So we want to use this offer. All right, now I don't want to do this cut and paste. So lots of times, let's use a for. So int key value over initial key. Can I not spell initial key twice at once? There we go. Now we don't want to add 1. Let's add key val to it. And as we add things to it, let's print it out to see what it looks like, shall we? Take this, and we'll see what our key looks like, our repeating key. Let's print it. All right, so here we are, we're adding, and then we start adding 1, and then we add a 2, and then a 3, and then a 4. And we can see it's adding it to one end of it here. So it builds it up, and builds it up. Excellent, just what we wanted. And here we are, we're printing it out once more at the end. That's because that one should be up here. There we go. Run that again. Okay, that's better. Empty, and now we fill it up. So now, well, that's the same thing as the linked list works, right? But we want to take items off. So here we took one item off, and it took the only item there. Now we've got multiple things in here. We've got 5 things in here. What happens when we call poll? Will it take it from here, or will it take it from here? Let's find out. What do you think? Have a think about it. What could it be? So the way we want to do this is we want to keep going until it's empty. So we go while our, what do we call it? We called it not repeating key dot is empty. So while we've still got some things in there, then let's take something off. So int, what are we calling this? Let's call this, call it keyval again. Why not? Keyval is equal to repeating key dot poll. And then let's print that out. We'll see how it reduces down. So here we've filled it up, and now we're going to start removing things. So it doesn't remove the 5, right? The 5 is still there, but it removes the 1. So the 1 has disappeared from here. And then next time we go around, it's the 2. And so it's taking it added from one end, and then it's removing from the other end, just like a queue should work. All right, excellent. Our queue works as expected. Very good. So we have a queue that seems to work. So the idea of this repeating key is not just that we take it or fill it up and take from the front, is that when it's exhausted, when it's finished, we go back through it again. As we can see here, the 3 gets used again here and gets used again here as we go through it. So we can use a queue to represent that. So we use a queue to store all the values. We take one off, right? So we poll, and then we enqueue it or offer it back to the other end. And then that value will move through the queue and it'll do a circle as it goes round. So it's constantly cycling those values. So let's see how that translates into our code over here. So let's fill this back up again. So this was SOUT. Let's just make some comments in here. Fill up the queue. And this one is empty the queue. And this will be fill up the queue. Okay, so we're going to fill up the queue again. It's actually initializing the queue here that we want to do. So what we should really do here is ensure that our queue is empty. So we can do a repeating key dot clear, and that will remove all the elements, as it says there, remove all the elements from here, so we can clear it. So make sure it's empty. It's always good when you start these things to make sure they're empty. If they're not, there could be a key still there. So when we fill it up, then we get more keys than we're interested in, or if we're using stacks, we think it's empty and it's not, you might get into trouble. So making sure your stack or your queue is empty when you start is very important. So you can use clear to do that. All right, so this should fill it all up. Let's just run this. All right, so we're going to fill it up. 1, 2, 3, 4, 5. And then the idea of our queue processing is for a particular string we get, we want to iterate through each character and take off one of the keys and then put it back on the other end is the idea here. Excuse me. So let's have a think about that. So let's get a message equals hello app dev is our message. And for each one of those characters in there, we'll want to take one character, get a key, do something to it, and then put that key back on the end of our repeating key. So we need to iterate over this message here. So we'll do a for each on that. So for each character, C equal from message. Okay, so it doesn't seem to like that because a string is not an array or an iterable. So we have to do it the old-fashioned way here, where we can do for int ci equal to 0, ci less. Always good to practice this. Ci less than message dot length CI++. Now, we're going to get each character and deal something with it. But first, let's just see how this key works. So an int, well, it's going to be how much we shift it by. So the shift is equal to, we want to get a value from our repeating key. So repeating key dot poll. So we take one off, and then we do something with it. Do something with shift, or what is it? It's actually shift character by shift. Makes a lot of sense. We'll leave that for a little bit. And then we want to take this shift and put it back onto the repeating key. So our repeating key dot offer, not CI, the shift. All right, so we take something off the front of the queue and then put it back on the end of the queue, and it should cycle around through there. So let's print out what this looks like as we do that. So we're going to take something off, put it back on, and let's see what it looks like when we do that. So here down here, we've just added things on and taken them off, but now we're going to add something and put it back on at the same time. Let's see what happens. Exciting stuff here. F6 run. Right, so here it is. Here's our initial key, and as we take one off, we put it back on the end. We can see the 1 here is moving down through this list. It's moving through, and then it goes back to the end again and moves through again. So it's a circular idea here. So we can keep reusing these items each time, and they'll change. All right, so we've got this key which iterates around and around and around. That's very cool. The next bit we need to do is actually implement this shifting idea.